Welcome to the Statistics Lab. Today, we'll solve an interesting hypothesis testing problem involving a chocolate factory and its premium chocolate bars. This is a t-test for single mean. Let's dive right in. Before proceeding further, I want to tell you that you can send us a message on Telegram to get your question solved. The link of the Telegram is provided in the description box. Okay, so let's proceed further. The question says that a chocolate factory claims that the true average weight of its premium chocolate bars is 150 grams. To ensure quality control, the factory manager selects a random sample of 25 chocolate bars and finds the sample mean weight to be 148 grams, with a sample standard deviation of 5 grams. The manager wants to determine if there is evidence to suggest that the average weight of the chocolate bars is different, higher or lower, from the claimed 150 grams. Use a 5% significance level to test this hypothesis. This question can be solved using two methods. One is the critical value method, and second is the p-value method. We will solve this question using both the methods for better understanding. Please watch the entire video for conceptual clarity about t-test for single mean. We will solve this question step by step. Steps include writing the given data, setting up hypotheses, calculating the test statistic, and then drawing conclusions based on both critical values as well as p-value method. Step 1. The sample size n is 25, the sample mean x bar is 148, and the sample standard deviation s is 5. The level of significance is 5%. The significance level is denoted by alpha, which is 0.05, and the claim of the factory is that the true average weight of chocolate bars is 150. Step 2. The true average can be denoted by the Greek letter mu. The null hypothesis says that the claim is true, that is, mu is equal to 150. The alternative hypothesis is that the true average is not equal to 150. An alternative hypothesis is always an opposite statement to the null hypothesis. Since we are testing whether the average weight is different, either higher or lower, this is a two-tailed test. In step 3, let's calculate the test statistic. Since the population standard deviation sigma is unknown, we'll use a t-test. The formula for the test statistic is x bar minus mu divided by the standard deviation s, which is divided by the square root of the sample size n. Substituting the values, 148 minus 150 divided by 5 divided by root 25. The numerator is minus 2 and the denominator becomes 1 as the square root of 25 is 5 and 5 divided by 5 gives 1. Hence, the final test statistic value is megas 2. Now in step 4 and 5, we find the critical values and make a decision based on the critical value method. Step 4 says that the degrees of freedom are n-1, which is 24. Hence, for a two-tailed t-test with alpha 0.05 and degrees of freedom 24, the critical value can be obtained from t-table or Excel. From t-table, the critical value is 2.064. If you do not know how to find the critical value in t-table, you can drop a comment in the comment box. We will make a separate video on it. You can calculate the critical value using Excel with the formula equal t(2t).0524. In the Excel formula, INV is used for the critical value, 2t is used for the two-tail, 0.05 is the significance level, and 24 is the degree of freedom. Step 5. Now we have the value of the test statistic as -2 and the critical value as 2.064. We can follow the given decision rule to draw a conclusion. The decision rule says that reject the null hypothesis if the absolute value of the test statistic t is greater than the critical value, or do not reject the null hypothesis if the absolute value of the test statistic t is less than the critical value. Here we can see that the absolute value of the test statistic is 2, and this is less than the critical value 2.064. Hence, we do not reject the null hypothesis. Okay, so the critical value method is completed. Now we can proceed for the p-value method. We calculate the p-value in step 6. The formula for p-value is 2 times 1 minus probability t less than absolute value of t. When we put the value of t and take the absolute value, the formula becomes 2 times 1 minus probability t less than 2. Here, this capital T follows students' t-distribution with 24 degrees of freedom. Mostly, the p-value in t-test is calculated using Excel. The Excel formula is equals 2 1 minus ts 2 24 true. Here, true is used to calculate the cumulative probability. This gives us a p-value of 0.0569. Now, in step 7, we make a conclusion based on the p-value. For the conclusion, we can follow the given decision rule. The decision rule says that reject the null hypothesis if the p-value is less than alpha, or do not reject the null hypothesis if the p-value is greater than alpha. Here, we can see that the p-value 0.569 is greater than 0.05. Hence, we do not reject the null hypothesis. One can verify that by both the critical value method and p-value method, the conclusion is the same. Both the methods arrive at the same conclusion of not rejecting the null hypothesis. Hence, we have completed both the methods. Now, we can write an interpretation for the conclusion that we have drawn. The interpretation can be written as follows. The null hypothesis is accepted. The true average weight of premium chocolate bars is indeed 150 grams. But while writing any final verdict based on the hypothesis testing, we must remember two things. One is the level of significance, and other is the provided sample data. This is because the conclusion may change when we take other levels of significance, say 10%. Also, if the provided sample data is different, the conclusion may change in that case also. In this case, we are provided a sample of 25 chocolates, which gives a certain sample average and certain standard deviation. Now, if someone gives a different sample, say a sample of 29 chocolates, then the sample average and sample standard deviation will change. Hence, we will get a different test statistics value. We will get a different p-value. Hence, the final conclusion may change. Hence, the conclusion may change when a different sample is provided to us. So, while writing any final verdict based on the hypothesis testing, we must include both the significance level and sample data. Therefore, the final verdict can be written as follows. At a 5% significance level, there is sufficient statistical evidence to support the chocolate factory's claims based on the sample provided. Please like the video and subscribe to the channel. Thank you for watching the video. If you have any doubt or if you want to get this PDF, message us on Telegram. The link of Telegram is given in the description box. Thank you. Welcome.